Imagine witnessing the collision of two cosmic monsters, an event so powerful it sends ripples through the very fabric of space and time. This isn't science fiction, it's reality, and it's confirming predictions made by Einstein and Hawking decades ago. But here's where it gets mind-boggling. These collisions are so distant and subtle that detecting them is like spotting a single grain of sand in a vast desert. Yet scientists have done it, and the implications are profound. In January, researchers using the Laser Interferometer Gravitational Wave Observatory, LIGO, detected a black hole collision, dubbed GW250114, with unprecedented clarity. LIGO, a pair of massive instruments in Louisiana and Washington, picked up gravitational waves, faint ripples in spacetime, created by two black holes merging. This isn't the first time LIGO has detected such waves. The first detection in 2015 earned a Nobel Prize. But this latest observation is a game-changer, offering a sharper view than ever before. And this is the part most people miss. These waves, predicted by Einstein in 1915 as part of his theory of relativity, were once thought to be too weak for human technology to detect. Yet here we are, not only detecting them, but using them to confirm theories about black holes. The black holes in this collision were each about 30 to 35 times the mass of the Sun, orbiting each other in nearly perfect circles before merging into a single black hole 63 times the Sun's mass, spinning at 100 revolutions per second. Maximiliano Isi, an astrophysicist at Columbia University, led the study and described this as a totally new view into the dynamics of space and time. Controversy alert! While most scientists celebrate these findings, some question whether we're truly seeing the full picture. Are black holes as simple as Kerr's equation suggests, described by just two numbers, mass and rotation? Or is there more complexity lurking beneath the surface? EC argues that the ringing of black holes, similar to the sound of a struck bell, supports Kerr's theory. But not everyone is convinced. What do you think? Could there be more to black holes than meets the eye? The observation also confirmed Hawking's 1971 prediction that the surface area of a merged black hole must be equal to or greater than the sum of the original black holes. This area theorem is a cornerstone of black hole physics, but this has allowed scientists to observe over 300 black hole mergers, including the most massive collision detected earlier this year between black holes 100 and 140 times the Sun's mass. But here's the bigger question. What does all this mean for our understanding of the universe? Emmanuel Berti of Johns Hopkins University calls LIGO's detectors hearing aids for the cosmos, allowing us to hear signals with unprecedented clarity. Lior Barak of the University of Southampton highlights the extraction of a second overtone in the black hole's ringing, a first in gravitational wave astronomy. Macarena Lagos of the Universidad Andrés Bello emphasizes that these observations are laying the groundwork for even more precise tests of spacetime and gravity in the future. As we peer deeper into the cosmos, we're not just confirming old theories, we're rewriting the rules of physics. But with each discovery, new questions arise. Are black holes truly as simple as we think? Can we ever fully reconcile general relativity and quantum mechanics? The answers may lie in the next collision, the next ripple, the next whisper from the universe. What mysteries will we uncover next? Share your thoughts below. Let's keep the conversation going.